Hello, OCSA family. My name is Shelley Stanfill. I teach physics here at OCSA, and in this video, I'm so excited to share with you a little primer on flipped instruction, what it is, when and why you might choose to use it, and how to do so most effectively in your classroom. Before we get started, I just want to affirm the incredible work that you do as teachers and remind us of the important truth that you, the teacher, are absolutely the most important and valuable resource that your students have as they go about learning. More so than any activity, any text, any video, you are the one who can really most effectively unlock learning for your students. And so I want to pose the question to us of how can we as teachers ensure that we are available to provide that expert support and expert guidance when our students need it most in their learning journey. Now, there are lots of different pieces to a student's learning journey, as we know, but I want to focus on two pieces of all learning, regardless of what subject it is that you're teaching. All of us engage in some amount of helping students acquire new knowledge and skills, getting introduced to new material that might come in the form of lectures or reading or demonstrations or discussions, but students are getting exposed to new ideas and new ways of doing things. And another key piece of this learning process is having the students use and apply that newfound knowledge to some sort of real-life problem or scenario, writing a paper, engaging in a debate, but they've got to be able to use it to really be able to understand it properly. And of course, we as teachers know that these two pieces of the learning process often occur in a cyclical kind of pattern where students learn new information, they apply it, but then as they're applying it, they discover they need to learn more information to be able to do it well. So as we look at these two pieces of the learning process, again, I want to ask the question of when in this learning process is your expertise most crucial to the student's success? So here are a couple different models of how we see teachers organizing these pieces of the learning journey. Under what we might call a traditional model, the acquisition of new information is done in class. Maybe a teacher lectures or provides a demonstration or models a particular technique or something like that. Students gather that new information, and then at home for homework, they are expected to try to use and apply that knowledge and those skills by working through practice problems or by writing a paper or producing their own new original work. And so in this model, what we're essentially saying is that the teacher is most crucial for the knowledge acquisition part of the learning process, but then the student needs to be more independent while they are applying that knowledge. Right? This model works great, at least some of the time. That being said, we have another possible approach that flips this order around, which is why it's called the flipped model. All right. So instead of having the teacher there for knowledge acquisition and the students working independently on applying it, we switch those around. So the students on their own acquire the new information for homework by watching a video or reading a text or doing some other independent activity to get them introduced to new information. And then in class, under the teacher's supervision and guidance, the students then use and apply that new knowledge, those new skills, to some sort of context. So in this model, we're saying that the most crucial part of the learning process for the teacher to be present for is in teaching the students, helping them to apply their new knowledge rather than in the part where they're acquiring that information. So when I first learned about flipped learning, then I immediately asked the question of which one's better? Like, what is the correct answer for maximum learning? And so again, we have these two different options, right? There's that traditional model where we're learning the new material, we're acquiring information in class, and the students apply it on their own at home. I did this a lot during my first year of teaching. It worked great plenty of the time, but there were also times when students would come in and say, it made sense in class, but then I went to try to do the practice problems for homework and I had no idea what I was doing. So with that problem in mind, when I learned about this flipped approach where students got new material and took their notes at home and then they tried applying it in class, I went, that's the solution to my problem. So my second year, I flipped everything, all the lessons, had the students watch video lessons and take notes at home, and in class we worked through those practice problems and worked on projects together. And again, a lot of the time that worked great, but there were some times when I was trying to put together a video lesson and I felt frustrated and stuck because I just thought, for this concept, I want to be co-constructing this understanding with the students. This is such a tricky concept to try to wrap your head around, and getting from point A to point Z, it involves a lot of tricky steps and ways of thinking about things, and I don't know if the video is the right way to do it. So I wrestled with the shortcomings of both of these approaches for quite a while. I backed off, I tried again, and ultimately what I landed at is that they're both great for different purposes and for different types of content. So there are some lessons in my class where the material is really conceptually tricky to make sense of, to try to understand what's going on, where we're trying to construct a model or put a lot of different pieces together there. But once we've done all that work of constructing that understanding, then it's not as hard to go about applying it to some sort of situation. For that material, I love using that traditional model because I see that the harder part of the learning process is in the acquisition of new knowledge, and I want to be there for that because that's the harder part. But there's other material in my class where at first it seems really simple. The students catch on quickly and they say, yep, that's the pattern, that makes sense, no problem. But then the act of trying to apply that to a variety of different situations with different variables at play, that's where it gets really hard. And so for those lessons, I like to use a flipped approach because in my mind, in those situations, my expertise is most valuable when the students are trying to apply their knowledge. They can acquire the knowledge in a little bit more of an independent format. So at this point, I use both approaches about 50% of the time for each of them. And it just depends on the content that the students are learning at any given time. So that's kind of our what, when, and why for flipping. I want to get a little bit more now into the how of flipping, how to do it well, how to integrate it into your outstanding lessons that I'm sure you are already delivering to your students. So one framework that blew my mind and made a huge difference for me in my flipping journey is the Explore, Flip, Apply sequence that was coined by Ramsey Musallam, who teaches science up in San Francisco. And so he kind of distills the learning process into 3 distinct phases, each of which occurs in a specific place for most flipped lessons. All right. The first phase is explore. That's the hook of our lesson here, where we're trying to pique students' curiosity and really get them interested and motivated and wondering and starting to figure out what's going on for this lesson and starting to observe and make connections among things. Okay, so that might be a question, a debate. Maybe you show them a video of a cool phenomenon, something like that. That's typically done in this model in class during that synchronous time, so students can be working together on it, so you get to enjoy seeing them get curious and ask those questions. Then when it comes time for students to acquire new knowledge, they do that at home. So that's the flip part of this model here, where then in this flipped instruction, our purpose is to just kind of build on all those things that students were wondering about during the explore phase, help them organize it, provide them with new terms, new frameworks that can help them make sense of all of the things that they explored. And then when they come back to class, that is the time when they apply that new information that they learned in the flipped lesson. And they can do that collaboratively. It can be creative. They can really be working together to try to understand what's the significance and the relevance of this new information. So to give you an example from my class, right now we're learning about collisions in physics. And so this is what this explore, flip, apply approach might look like for a lesson on collisions and conservation of momentum. So in our explore phase, which again is done during synchronous class time, I show students videos of test crashes for cars and bumper cars and people holding exercise balls and running into each other and all these weird collisions. And it's lovely and things go flying and it's very exciting. And we use this and we start trying to identify what's going on in these collisions. What's the same? What's different? How are we making sense of this? And then to try to help guide their thinking about it, I throw out the question of, hey, bumper cars are fun. Why don't we just make all cars bumper cars? And immediately students start to have opinions about that. Some of them are like, yes, let's do it. Life's a party. Others are like, no, I would be way too tempted to crash into everything if we did that. And so our goal then throughout this lesson is really to figure out how we can answer that question. So then students dive into a lab together. They start crashing things into each other. We're sticking with like carts on tracks rather than like actual cars. So we try to, keep it safe and everything. But they collect data, they're crashing things into each other, they're making observations, they're starting to identify patterns in terms of what's similar about these collisions, what's different about these collisions, what are the types of collisions that we're seeing, and they start to construct models of what's going on in these different situations. Once they've started to get their feet wet and they're seeing the different ways that things can collide and seeing some of these patterns in terms of what's going on, that's when I introduce the flipped lesson. So on their own, during their asynchronous time then, students watch a video lesson that I've put together in which I kind of summarize all the patterns that they noticed, give them introductions to new terms to help them communicate those patterns effectively. And I include some questions along the way in the video to make sure that the students are kind of checking their own understanding and make sure that everything's landing okay. And then once the students have that new information, then we come back to our synchronous time together in class and we apply it. Students solve practice problems, analyzing various collisions, and they ultimately then are able to produce an answer to this question of, should we make all cars bumper cars? So that's one way that this explore, flip, apply sequence might look in a typical class. So a few more tips for flipping if that's something that you decide you want to try out. First of all, if you're doing video lessons, try to keep them short, maybe 10 to 15 minutes. Bear in mind that the students are going to need more time than just the length of the video. They're going to be taking notes. They might need to go back and re-watch tricky parts. If you embed questions, they'll need time to think about the questions and answer those questions. So even though the video is only 15 minutes, the students may be spending significantly more time on that lesson. So we want to be cognizant of that and not burn them out completely. I know this is hard for some of us who are a little bit more shy, but I really encourage you to show your face in those video lessons. Use the webcam in there so that the students can see you as you're presenting this material. It's been shown to greatly increase student engagement as they're watching the video, and it helps them pick up on those nonverbal communication cues as well. And again, I would encourage you, ask questions throughout the video. Actively Learn is great for this. You can embed open-ended or multiple choice questions along the way, and then you'll get the report to see how the students answered each of those questions so you know what they got and what they didn't get. It's also great for helping the students to assess their own understanding along the way and see if they're getting it. And so what I'll often do is I'll throw in a question. The video stops automatically then for Actively Learn, and they have to answer it before they can proceed. So I throw in a question, the students submit their responses, and then immediately after, as they continue the video, I answer the question for them as well and explain it so that they're able to monitor, did I understand that, or what do I need to be thinking differently about this? In addition to asking the questions, I also want to make sure that you're answering those questions as well. I love to, at the end of a video, include a quick open-ended question of what are you still confused about? What do you need clarified? And then I can either answer those questions directly in Actively Learn or address them with the whole class the next time I see them. I haven't tried this, but I've heard great things about partnering up and co-creating a video with a colleague. I bet Zoom would be great for this. You could film that using the screen sharing feature so the students can see that. but then you and a colleague could both be on that call helping to explain the material. Another way to use this that I've heard of before is having one teacher take on the role of student, essentially, and asking those questions and exposing those misconceptions that often come up during class. So it feels more interactive, it feels more like a conversation, and you don't have to feel weird about talking at a screen with no one there on the other side. Last suggestion and reminder is that it doesn't have to be video. You can have students acquire new knowledge with texts, websites, simulations, a bunch of other things, depending on what makes sense for you and your class. A few last resources for you to consider. The book Flip Your Classroom is what got me started. It's thin, but it is chock full of great ideas and information. It's written by two actual teachers who flipped their own classroom and tried all the different iterations of it. They also have a website called the Flipped Learning Network, which is just an absolute treasure trove of teacher stories, suggestions, how-tos, both big picture and nitty-gritty, which is a great resource for us. I mentioned Ramsey Musalam's Explore, Flip, Apply approach earlier. He has a blog called Cycles of Learning, which is absolutely terrific, not only for flipping, but a bunch of other things as well. And I feel a little weird including my name in there as well, but I would be more than happy to work with any of you and talk with you further about what flipping might look like in your class and how to do so effectively. Thank you so much for listening in on this presentation. You all are absolutely brilliant educators, and I just can't wait to see what you all come up with next. Thank you so much.